Okay, so in machine learning, basically, the whole module of machine learning, all the algorithms are divided between two parts. The first part is supervised learning, and second part is unsupervised learning. Okay, so whenever we are talking about the supervised learning, let me write it down. Supervised learning and unsupervised learning. And also, when we are talking about the supervised learning, so supervised learning are divided between two parts. Okay, first is we will discuss about the regression techniques. Okay, and second will be the classification. So whatever algorithm which are available inside supervised learning, we will be discussing around regression and classification only. And in case of unsupervised learning, we always try to discuss about the clustering algorithm. Okay, clustering and basically the dimensionality reduction techniques. Okay. So in case of supervised learning, from the name only you can understand that in case of supervised learning, we will always have some kind of label data. Okay. So label data can be, it can be any dependent feature, or in case of classification, you will have some labels like between two classes, three classes, or multi-class labels. So there will be some kind of uh, label data in our data set. Okay. In case of unsupervised learning, we don't have any kind of label data. It is like simply a kind of, you will say, we will have a data set where we will have to find the groups of people as per the cluster. Okay. Just like suppose we want to open some kind of shops, Walmart shop, or we want to take a group of people on the basis of we want to analyze the some specific product, how it is going to be popular, or which product is famous on what range of people, what age group. So all those things we try to do with the help of clustering algorithms. Okay. And then in case of unsupervised, we have some one more technique which is called as dimensionality reduction technique. So this is basically for reducing the dimension in our data set, because we all know that in our real case data set, we will have multiple features. For features is nothing, just the columns. So whenever we have multiple columns, for us or for the algorithm also, it is very much difficult to analyze, to do the computation, and then find some findings according to that. So that's why it is not always possible for a machine, for algorithm to understand properly. So we try to make it, we try to reduce the dimension, we try to reduce the column, we try to select the important features, and according to that, we try to give to our model. Okay. So the whole machine learning part is covered inside these topics only, supervised and unsupervised. So whenever we will start with supervised learning. We will try to understand different algorithms which are there in regression, like linear regression. Linear regression is there. For classification, we have logistic regression. Then we have ridge regression, lasso regression, decision tree, random forest. So all those algorithms we will try to understand, and we will try to see how these algorithms work in the background. Okay. So before starting this, we have some prerequisite, means before starting going through these algorithms. Like first we have to go through topics related to NumPy, which is a very important library. I think previously also we have used some of the modules from the NumPy. So we will try to discuss in detail how NumPy is important and how it is beneficial in our machine learning task. Okay. So we'll try to discuss in detail. Now we have Pandas library. So Pandas is a very powerful library in case of manipulation, in case of exploratory data analysis, in case of any kind of filtering of column. So whatever manipulation you do in dataset, you can easily do with the help of Pandas library. So in in comparison to Pandas, nowadays we have multiple libraries which are similarly helping the same features like Pandas, like Dask is there. So this is just the add-on thing I'm explaining you. These are not required. Just the add-on libraries I'm explaining which are similar to Pandas, which you can explore and try to use and see how Pandas are different from this Dask or Polars. Okay. So these are the libraries which are similar to Pandas, but somehow they are different in computation. They try to work in parallelization, multiprocessing. So all those things can be done with these libraries. But since the community is very less in comparison to Pandas, so people try to use Pandas most of the time, and currently very less community or less product, less company try to go with Dask or Polars. Okay, but you can try to explore, because later on, if you will have some kind of use case related to huge data set or some kind of where you need a parallel processing, so in that case you can try to execute and try to see how efficient it is in comparison to Pandas. Okay. So these are the libraries which are very much important. And then we have some libraries like which are very much helpful for visualization tool. Like Seaborn is there, Matplotlib is there, and then we have Plotly. So these are some libraries which help us in doing the visualization. Whenever we try to have any kind of data set, we try to visualize them in 2D graph or 3D graph and try to see how my data is dependent with our different features, how independent features uh, dep means helpful in finding the dependent variables. So all those things we try to find with the help of visualization tool. Okay. So these are the libraries which will be very much helpful in making your data proper, in formatting your data, in cleaning your data. And after that, you can go through the regression and classification technique to build your model. Okay. So first we'll try to cover this part, NumPy, Pandas, and visualization tool. And then we will try to go through the regression topic in detail and then the classification. And at last, we will try to understand the unsupervised learning also. So first we'll try to discuss with NumPy. So till now, any question, anyone? Any question, anyone?
Yes, Professor.
Yeah, sure.
Hello. Yes, did you say that Dask and Polar are separate from work, or they are inside Pandas?
No, they are separate. Just like
They're separate.
Pandas is a library which can be done for analysis. So similarly,
Mm-hmm.
Dask and Polars are also separate libraries. But
Mm-hmm.
some of the additional features like parallel processing, they can be used for huge data by dividing them into chunks, and then we try to do any kind of manipulation. So for the
Okay.
parallelization thing, we can use this Dask and Polars library. So basically, these are the libraries which work similar like Pandas, but some with some additional features.
Okay. So they complete the Pandas features.
Yes,
Like,
correct.
okay. Okay.
Okay. Okay. Other members, any
Thank
question?
you.
Yeah, thank you. Other members, any question? Okay. So maybe we can start with NumPy first. Okay. Is my screen visible, everyone?
Yes.
Okay. So let's talk about NumPy. So NumPy is nothing, whenever we try to use NumPy package, we will be talking about the arrays. Okay. So we have a common confusion with how arrays are different from the list. Okay. So we will try to have a discussion around this, means why arrays are different and how lists are different. So arrays and lists are both data structure used in Python, but they have some key differences. So you can see data type wise, list can contain elements of different data types, while arrays are designed to hold elements of same data type. In other words, arrays are homogeneous and whereas lists are heterogeneous. Okay. So we all know that lists are mutable. We can use any data type inside the list. But in case of arrays, we generally, it is very much efficient, and mostly we try to use this in case of numerical data. Means whenever we want to do some kind of computation, some kind of calculation, some kind of matrix calculation, or some kind of concat operation with the numerical data, we try to use this arrays. Okay. So in case of list, it is not possible that we can create a list for the huge data. Okay. But in arrays, if you will say, it is very much efficient, since it is means the this NumPy package is built on C++ language. Okay. So whenever we have such kind of you can say, which are built on C or C++, those libraries become very much powerful because they are computationally very fast, and for whenever we are doing some calculation with those libraries, it becomes very much efficient for the CPU memory also. Okay. So this NumPy package becomes very much efficient whenever we do any kind of mathematical operation or mathematical calculation with any kind of data, wherever we have some numerical data. Okay. So you can see memory efficiency, performance, flexibility. So these are the features which helps arrays in computing and making it efficient for the numerical data. Okay. So that's why whenever we have some data set, we try to use, for numerical data, we try to use arrays, and we try to do computation with the help of NumPy package only. Okay. So you can see the summary. Arrays are more suitable for numerical computation, large data set, and mathematical operation. So it is not like arrays are, means you will not be able to observe just with a few data, but when you will have large data, when you will try to perform some mathematical computation means some operation you want to perform, like some formulas you want to implement. So in that case, this NumPy package will help you a lot. Okay. Just like we write some formula like uh, a square plus b square. Okay. So we can write the same formula using this NumPy package. Okay. And that will give you the result much faster in comparison to list or any other data type. Okay. So whenever we are talking about any package related to NumPy, Pandas, Seaborn, Matplotlib, anything, you always should try to go to its official documentation, because if you will see, let me go through you. If you will try to see in their official documentation, some basic things are mentioned. First of all, you will see the package release version. Okay, this you can see. So when this package was released, what is the latest update? All those things can be seen in their official documentation. Okay. And if you will see, there are some beginners, what we should follow, what are the basic syntax we should follow for this package. All those things you can see here. Okay. So this becomes easier for us, that from where to start and what are the basic commands, basic uh, imports we need to do for this particular package. Okay. So for installation, you can see either you can do installation with Conda. So Conda is also one kind of package installer. You can either install with Conda or pip, any one of them. And then you can simply import this package using this import numpy as np. Okay. So this will give you the all the functionality, all the modules which are inbuilt in NumPy package. Okay. So this is as simple as that. You don't have to do anything more. You can see these are the some important things mentioned. The NumPy package is used extensively in Pandas, SciPy, Matplotlib, scikit-learn, scikit-image, most other data science and scientific Python package. Okay. So just one example I will like to give for this NumPy. Since whenever we do computation, it is understood that we can do computation with the help of numerical data. Okay. But just think of images. Images, we cannot uh, use images as it is. Okay. But with the help of NumPy package, you can you can convert the image into numbers in arrays, and then you can use that image as a numbers, and then you can do the manipulation also. For that image, if you want to suppose if there are you want to build some kind of image classification. So in that case, you need to convert that image in some kind of array format. So at that time, this NumPy package becomes very much helpful. Okay, this gives the power to convert any other data type using OpenCV or Pillow. You can try to convert that image into NumPy array, and then you can perform the multi-classification or any kind of classification algorithm you can apply above it. So these things makes NumPy a very powerful algorithm. So apart from this, if you will try to see packages wise, yes, you can see when we write the list, we define inside the square bracket. We all know that. So this is the same thing. Here you can see I have just tried to print the type of list. So this is giving me a list. And similarly, if you want to convert this list to NumPy array, you just need to give this NumPy.array. So whenever we will try to give this NumPy.array, it will try to convert the list to array format. Okay, like this. So this is how it is. The class will be given NumPy.ndArray. So ndArray means and dimension. Okay, whenever we are talking about array, it will be and dimension. Now let's see what kind of array we can have. First of all, you can see I'm taking a one-dimensional array. So whenever we have a single row or single bracket, you can say it will be a one-dimensional array like this. But whenever we will have two brackets like this, you can see I have taken two arrays inside it, 1, 2, 3, and 4, 5, 6. So it will be the two-dimensional array like this. You will have two brackets. Okay. Where we will have two rows and three columns. Now, if you want to create a three-dimensional array, you can create this also. Okay. Like this three array you can take inside, and then you can create a three-dimensional array like this. So when you will try to check, it will be like three brackets like this, where you will have three columns and three rows. So this is how we can try to create n-dimensional array using this NumPy package. Now we have some basic function to check what are the things present inside the array. So this is one function to check the dimension. a1.ndim. So ndim helps you to check the dimension of a particular array. Okay, so you can check for a1 we were having one dimensional, so that's why it is giving one. For a2 we were having two dimension, so it's showing two dimension, and a3 we're having three. Okay, and we can also see the size. What are the size of the elements which are available? So we can also check the size. So see, these are the some small functionality which are available inside the NumPy package. Okay. Shape. Now you can also check the shape. Shape means how many rows and how many columns you are having. So if you want to check the shape, you can also check with this shape library, shape function. So a2 shape will give you the how many rows you have and how many columns you have. Okay. Now some important functions like you can see here, np.random.random. So This will help you in creating or generating the numbers. First, you can see 2 to 100 I'm taking. I'm generating a number between 2 to 100, and our array format should be 2 into 6, means 2 rows and 6 columns. So you can see I have created a two-dimensional array where I'm having a 2 rows and 6 columns. So it will be 2 rows and 6 columns, 1, 2, 3, 4, 5, 6, like that. Similarly, you can create using this 2 comma 50, 2 in 2 comma 2 comma 3 comma 4. So it will try to create a two arrays inside it in 3 dimension. Okay, like this. It will try to create a 2 array with 3 rows and 4 columns. Okay, so these are some basic functionalities. What are the functions? What are these? Random function is used to generate random numbers. Random dot randint is help to generate random numbers between this 2 comma 50. Similarly, you can see np.random.rand. So if you want to generate a number, okay, between 0 to 1, you can generate using this. You can see 5 comma 4. So I'm having 5 rows, 1, 2, 3, 4, 5, and 4 rows. Okay. And using this rand.n, you can see you have negative values also. So each of these functions will have some specific meaning. This is for generating only positive numbers, and this will help in generating negative as well as positive both. Okay. So these are some small functions. So maybe this reshape is also very much important. When we try to see reshape, basically used to, if you want to convert your array in, suppose you have 2 into 8. Okay. So the maximum combination will be 16. Okay. 16. So whenever you will try to convert, so it should be the result should always be 16. Like either you can convert this between 1 comma 16, 16 comma 1, or like 8 comma 2. So like that. So whenever you will try to convert, the result should always be 16. So you can do the reshape operation also. Okay. So these all things you can do with the help of NumPy. Like this, you can see. Previously, I was trying to do into 2 comma 8. So we were having 2 arrays with 8 columns. Now we are having 8 rows and 2 columns. Similarly, 16 comma 1. So we'll have 16 rows and 1 column. Okay. So these are some functionality. So when I will share this notebook, I'll try to execute, try to see, and try to check with different numbers. Try to change these numbers, try to reshape, try to use some random numbers and to generate the numbers. Okay. Now indexing. So you must have done the indexing operation in list also. Okay. So same thing can be done in array also. Okay. Same slicing and indexing. So you can see A1, I have taken in a square bracket index 0. So you are getting the value 4. Similarly, you can also do the slicing operation between 2 to 6. So if you want to do selection 0, 1, 2. So from 6 to from 2 to 6. So it will give me the value 6, 7, SUDH 34.565. So you can do the slicing as well as indexing operation. Okay. So 2 to 6 with 2 steps. So all those operations can be done with the help of arrays also. You can see this one to reverse a string. If you want to reverse the elements inside a array, that also can be done. So these are some basic functionality which are similar to Python in list of how we used to do. Apart from this, let me show you some important one. Hmm. Let me show from here. Okay. This one you can see. Working with mathematical formulas. Okay. For this example, this is the mean square error formula, a central formula used in supervised machine learning models that deal with regression. So when we will discussing the regression algorithm, we will discuss this formula, which is used for finding the error between your predicted data point and actual data point. So this formula is used. So you can see, I am taking a simple formula, 1 upon n, summation 1 to n, y prediction minus yi whole square. Okay. So y prediction is your predicted point and y is your actual data point. Okay. So you can see, you can use this formula with the help of NumPy package. Okay, like this. So how easy it becomes. If we have an understanding of NumPy and we can implement any formula, just think, for any data set or any column, if you want to build your own formula and implement for any particular column, then you can build your own formula and you can implement. So at that time, it becomes very much easier and efficient in computing and getting the expected result from your uh, expected means your custom formula which you want to create. So this is the same formula written 1 by n multiplied with np dot sum. So these are the function used for np dot sum, and then we are using np dot square prediction minus label. So this prediction will be the predicted data point, and this label will be your actual data points. So like this, the prediction will be in this array format, and labels will be the actual data points. Okay. So this formula you can try to use. You can try to calculate with different algebra formula like a plus b whole square, a minus a square minus b square. So all those formula you can try to implement, and you can see either you are able to perform or not. Okay. So you can also save array variables. You can see this one. You can save it with file name dot npy. Okay. If you want to save any variable or array in some format, you can save it as well. And if you want to load, we can use this np.load. So these are some important functionality which can be used whenever we are having huge data set, just like in images. If we are computing for some images, so we try to store in some variable, and then we try to use this variable to compute for our image classification or image any such kind of task where we will have large amount of array data. Okay, so there we can use this functions. Yes, you can see this one also. So whenever we will try to use the pandas library, you can see we can directly fetch the particular columns and check the values. Okay, we no need to go through the whole data set. We can easily try to filter the columns and go for the specific data which we want. So it will try to give you the array format. Okay. So these are the few functionality which you can try to see. All things are mentioned very properly. Okay. You can try to visit this official documentation page and try to see what are the different functionality. It will be much easier to execute for you. Okay. See. This is one with matplotlib, you have the access to an enormous number of visualization operation. So whenever we have some kind of, if you want to create a line space, okay, if you want to create a line space for 0, 5, 20 for the 1D array like this, so you can try to create using this line space also. And if you want to create with the help of 3D diagram, you can see you can try to create like this also. So this all visualization, it will be much clear when you will have a some data set, and when you will try to use that data set to create a graph. Okay. Projection, we are giving 3D. Okay. So these are the some functionality. Maybe I will share this link. You can try to go through, try to execute, try to see. I will share the in the drive link, the notebook file as well as one PDF. You can try to see the different mathematical operations which can be done with the help of array. And if you find any issue, you can just uh, ping me for that particular problem. Okay. Okay. Till now, any question, anyone related to NumPy? Anyone? Because see, these are the function when you will try to execute, it will become more clear. It is not like if I will show here, you will see the result, it will be understood. You need to go through each functions, you need to execute, try to see the result, try to see how the arrays are changing, what are the dimension, how to reshape, all those functions. Then you will be able to understand at that time only. Okay. That's why I'm saying that try to execute and try to see the result. Okay. Can I move on to pandas topic?
Sure.
Okay. So similarly, like NumPy, we have a package pandas, which is very much powerful. You can see. Mhm. Show you. Mhm. So first of all, let me show you one. uh, So you can see this is a PYP package installer page. Okay. So this is a kind of, you can say, uh, all kind of library which are required for Python. You can get on this PYPI org website. Okay. So any package which are required for Python, you can get on this particular package installer. Okay. So in this, you can see the installation first. So we can either install with Conda or this PYP package. So both using this both you can try to install, and then you can see the documentation. This one. So whenever you are starting, so see how easy it becomes. In each of the library, either NumPy or Pandas or Matplotlib or any kind of library, whenever we try to go to their official page, there is something called as getting started. So if you will try to go to that section, they will always try to explain in from the basics. Means what is the use of this package and how to understand what is this package meant for. Okay, just like you can see pandas. So in pandas, whenever we are talking about the pandas, we are talking about the data frames. We will be always be dealing with the data frame. So data frame is nothing. We will have in data frame, we will have the column and rows. Okay, just like tabular data, we are having column and row. The only thing is that pandas try to convert uh, inbuilt, try to work with the help of with the data frame. Okay, just like NumPy try to do the computation in an array format, pandas try to do the manipulation with the help of data frame. Okay, so whenever we are working with pandas library, we will be working with the data frame only. Okay, so you can see we have a simple data name where we are having the name of a person, and then age column where we will have age and sex, either male or female. Okay, so when you want to convert this using pandas library in data frame, just you need to do pt.dataframe. Okay, so this is the format we try to have our data to create any kind of data frame like key and value. Okay, key value pair. So age will be your key and your data will be your value. Okay, it can be list like that you can create. And whenever you will try to use this pd.dataframe, it will try to create a data frame like this. You can see name will be created in one column, age will be created in one column, and sex will be created in one column. Okay, with a row as 0, 1, 2. So this is how we try to create a any data frame. Okay. So it will be the similar like this, where how we work in Excel.
Professor,
Yes.
is that same like a dictionary, or is it different? It's like the same.
Yes, it's same, but the thing is that see, you are using this data frame. Okay.
Mm-hmm,
So whenever
mm-hmm,
we are trying to convert to data
mm-hmm.
frame, we try to use this function. Okay, pd.data
Okay,
frame. Okay.
okay.
So it
Mm-hmm,
is a kind of data type you are taking to create a data. Okay, this is the kind of data you are creating. So we try to use this data to convert to data frame.
mm, okay,
Okay.
okay. Mm-hmm,
So each column in a data frame is a series. Okay. So it means that whenever we will try to filter any data, you can see I am filtering here DF DF age. Okay. So each column in a data frame is a series. So whenever you have any column, just like name, age, or sex column, so we will have in a series format. So series is nothing, you can say a type of, uh, you can say a type in a data frame. Okay. Whenever we are checking in data frame, what are its types? So it will be always be showing in series kind of, see, when selecting a single column of a data frame, the result is Pandas series. Okay, to select the column, use the column label in between square brackets. So whenever we will try to do any filter operation, it will try to uh, do the selection as per the series. Okay, like DF age, okay, or DF name or DF sex. So all these things we can do with the help of this. This DF is nothing, is your variable name, this variable name. Okay, this you have created. DF is equal to pd.data frame, and this variable name you are trying to do for the manipulation. Manipulation means you are trying to filter. So currently I am filtering the age column. So it will only give me the age data. Okay, like this. Okay, and it will also show the data type. So this age column, the data type is int64. Similarly, you can see ages period.series 2235 name age. So if you want to create also, you can create in this manner. Okay. So this will both give you the data frame only. So you can also, if you want to check for the max value, you can check using this max function. So max function is present inside Pandas to check the maximum value for that particular column. Okay. So these are the some functions. Maybe I will try to talk in detail through this. Okay. In this you can see. So here I am importing the Pandas library. Okay. And then I will share this CSV file as well. So this is the CSV file I'm using, sales data underscore final.csv. So I'm importing this library, and this is the format is encoding I'm using. So if you will see, whenever you try to import any kind of file, either it can be a CSV file or TSV or Excel file or JSON file, so each will have some format. Okay. So according to that, we try to provide in Pandas, there is an inbuilt function of encoding format, which you can try to use and you can load your data. So this encoding is a kind of hyperparameter for this Pandas. Okay. So like suppose you have UTF-8 format. So all those formats you can try to mention here, and then you can import your file. It is not like compulsory, but sometime it may be possible that your data set is in either comma separated or some kind of colon or hyphen separated. So in that case, you can try to provide the hyperparameter that in my data set, it is comma separated or hyphen separated. According to that, you have to create a data frame. So you try to mention what is your data type, what kind of data you are having, and according to that, you can load your data or convert your data into data frame. But suppose if I am not having any kind of this encoding or something, so I will simply use this thing, this much, to load the data like this. Simple. Okay. I will use this much. If I am using the Excel file, so I will use this XLSX like this to read the Excel file. If I'm using TSV file, I will use TSV. If I'm using JSON file, I will route JSON. Okay. So we have different read extension for the pandas. You can try to go through the official documentation and you can check. Okay. So these are the some basic extension which are available for loading the data. Now I have loaded this data. Now I want to check for the columns. So you can easily check with the column function. Okay. So this df.columns will give you the all the columns which are available for your data set. So currently I'm having very less. You can see I'm not having much. But suppose when you have 80 features or 80 columns or 90 columns, in that case, this column feature becomes very much helpful to see how many columns you are having and which to use. Okay. So at that times, df.columns will help you to know the what are the features are available. Now after that, this df will give you the data frame, all the data, whatever is available in your data set. So this is the data I'm having. Now, if you want to check the tail, tail is nothing. We have two things. One is df.head. I think df.head is not mentioned. We have something df.head and df.tail. So head means nothing. This try to give you the first five row value. Okay, first five row data it will try to provide. So suppose for large data, it is not possible to check all the data. Suppose this is having 51290 rows. So it is not possible that you will be able to see all the rows. You can see I am able to see only 0 to 4. Then I'm able to see 51285, 51286. So that's why we have some functions to check the first five rows. And according to that, we try to check the first five row of our data set. Similarly, if you want to check the tail of the tail will give you the last five rows. Okay. 51285, 51286, 51287, 51288. Like that, it will try to give the last five rows. Okay. So this will give you the means understanding that what is my data and how the rows are there in my data set. Okay. So df.column clear. Okay. Now say this one. So this is the data frame I'm taking and I'm using two brackets and I'm giving the column name. So this operation will help you in filtering of the columns. So whenever you will have some data set and you don't know which how much column to use and you want some specific columns. So in that case, you can use this filter operation like this df double brackets and you can give the column names. So only that columns will be available for you. So order data, ship data, and customer name. So these columns currently I'm trying to filter and check. So I can try to filter in this manner. Now, if I want to check the column, what is the type? You can say pandas.code series. Okay. So this is a type of column we are having inside a data frame. Now, this is one important feature, df.dtypes. So this df.dtypes help you to know the what is the data type of your each column. Okay, suppose you have this much features, this much columns. So if you will try to check df.dtypes, it will try to give you the what is the data type. For order ID, you are having object. For order date, you are having object. For discount, you can see it is float. For quantity, it is integer. So all this, what are the different data types, it will be able to give you. And from this, you can understand what are my integer data type, what are my float data type, what are my object data type, all those things. Okay, so this becomes easier for understanding what are the data types available in our data set. Now this is for filtering a individual column, df profit. So just I am trying to filter the profit column. Okay, suppose similarly if you want to filter the profit and year, you can filter like this. So these are some important functions which are available. Now if you want to check, let me show you. df.columns describe. So this is what one important function inside Pandas, df.describe. So this df.describe will give you the few of the most important things like count. What is the count is available for your quantity, for discount, for profit, for shipping cost. So this is the total count 51290. Okay. So this will give you the 51290 is the total count for this quantity, for discount, for profit, all those details. Now we have mean, it will try to give the mean of your particular quantity column for discount, for profit, all those things. Then standard deviation. So this is the standard deviation for this quantity. Then mean value, what is the minimum value for this quantity column, discount, profit. Then what is the 25 percentage for this quantity? What is the 50 percentage of the quantity? So all these details you can easily understand from this df.describe. So what are the maximum value? What is the minimum value? So all those details you can easily understand from this df.describe. Okay. Now we have some important features like the df.dtypes equals to object. So similarly, just like we were checking the data types, we can also check the Boolean expression, like either it is true or false. So if you want to check df.dtypes, it is same, just you are adding object. Means which are the columns are object or not. Okay. So in that case, you can give that object in a string and you can check. If you want to check for float, so you can also check for the float. So these are the Boolean expression also you can check with the help of df.dtypes. Okay. Now, this is one way to check the count, unique, top, and frequency. Okay. So this is the one technique also. But most of the time we try to go with df.describe. This will give you all the details. So this is just one other way you can try to check the index as well as the describe. Okay, as per the object I'm checking. So you can see, let me explain in some other code. This one. So suppose I want to filter up, I want to do some filter operation. So first I want to do the filter as per some particular column and particular value. Okay. So you can see I'm taking this df.stat. Okay. So first I'm trying to filter the df.stat and then I'm trying to, from the state column, I'm trying to filter the specific value. So this is the specific state name given California. So according to this, we will try to filter the whole data frame. Okay. So now you can see I'm just filtering the California state data. Okay. So this is having 2001 rows. Okay. So this kind of filter operation you can also perform with the help of data frame. If you want to filter some specific value from a particular column using particular column, then you can also use this filter operation. Okay. This value count is also important. Value count is important to know what is the count available for that particular value. Suppose I want to check for this df state, for a state column, what is the value I am having for California, for England, for New York, for Texas, and similarly. Okay, so you can see the count for California, you are having 2001. So if you can see when I try to do the filter operation, it is having the same value. Okay, so this will give you the value counts as well using this value counts. Okay. Any question till now, anyone? Are you able to understand these commands?
Yes.
Okay. You can check for null values as well if you want to check null values for that particular column. So all those things you can do. See, similarly, how you are building logic. Suppose you want to find the even numbers, odd numbers. Okay. So prime numbers. So you try to build a logic with the Python code. So same thing you can build with Pandas library also. That much free hand you have. It is not like any restriction is there. If you want to filter any specific value, if you want to filter with 2 columns as well, maybe somewhere I must be having. Let me show you. This one you can see. Okay. So first I'm checking the profit column. Okay. Then inside profit, I'm checking the maximum value, which is having the maximum number. And now I'm giving the customer name. So for which customer, what is the maximum profit in the profit column? So that also you can get. So the only thing is that you need to prepare your code according to this. Okay. So according to data frame, you need to prepare, and then you can easily get your desired output. Okay. Is it clear, everyone? Any question? Anyone? Okay. So maybe I will share this notebook file. Okay. I think if you guys will try to execute this code, then it will be more easier and you will try to learn a lot. So I will try to share this notebook file. You can try to go through and try to execute each code. If you find any issue, command, okay, try to do some, like suppose you have given 3 columns or something. Try to see the command. How in data frame we try to give for 2 columns, for 1 column and 1 value. So try to see, and according to that, you try to change the code. You will be able to get the output. Okay. The only thing is that you need to prepare this code as per your desired output you want. So I was talking about this Dask and Polar. So I wanted to show you how these two things are different. Not different, some additional features we are having. So you can see this Dask is a library. You can see. So you can see how we can import the Dask. It is similar. Import Dask.array as D. Sorry, somewhere it's going fast. So this is the how you can install this Dask using conda or pip. Okay. So this is the official page. You can try to visit and try to see what are the features they are providing. Basically, it is used for maybe you can see task functionality. Python has grown to become the dominant language both in data analytics and general programming. The growth has been fueled by computational libraries like NumPy, Pandas, and scikit-learn. However, these packages were not designed to scale beyond a single machine. Dask was developed to natively scale these packages and the surrounding ecosystem to multi-core machine. You can see. So this is the features used for multi-core machine, and distributed cluster when dataset exceeds the memory. So in case of Pandas, whatever things you execute, it is on your memory, okay, on your local system memory. So that's why sometimes it becomes very much difficult for, suppose you have a data set of 50 million, 60 million. So it will be very difficult to perform this task. Okay, so at that time you need GPU, either you need GPU or you can try to go with these libraries like Dask or Polars to execute the huge data set. Okay, so this try to give you the freedom to use the multi-core machine and distributed cluster to use for a big data set. Okay, so this is same thing. You try to create a chunk and then you try to chunk means you try to divide your data. You don't directly take the whole data. You try to divide it in chunks and then you try to perform the EDA just like Pandas. Okay. So maybe I will share this. You can try to go through. Maybe one more is there. Yes, you can see this Polar the data frame for the new era. Currently it's 2 million plus download to date. GitHub star 2K plus. So this is also growing fast. Built by developers for developers to achieve up to 50x performance. Polars was benchmarked against several other solutions on the independent TPC benchmark. The benchmark aims to replicate data wrangling operation used in practice. So basically it is used for installation wise, you can see pip install Polars. It is same, like nothing changed. The only thing is that it tried to provide you the multi-processing thing and you can easily use for the large data. Okay. Maybe you can try to explore and see if it is helpful or not. Okay. It is not just the add-on thing I am given to you. Maybe you can learn what are in the market, what things are going on, similar like Pandas. In Pandas, I think just the latest release also came. If you will see the CUDA version. Uh, Pandas now can be used for the CUDA version as well. I'm not able to get that particular. You can see this one. It is by NVIDIA official documentation page. You can see you can use this Pandas now with the help of your GPU also. Okay, so you import this CUDF for the CUDA version, and then you can use the CUDA as well, like this. You can see. So it can be used for large data also. CUDF supports multiple file formats, text-based formats like CSV, TSV, or JSON. Columnar-oriented formats like Parquet and ORC. This Parquet file basically it is used for big data. Okay, just like CSV file we are having. Similarly, we have Parquet file also. So Parquet file is in very huge amount of data, huge size. Okay, 1 TB, 2 TB like that. So that type of data you can also use with the help of this CUDA version of Pandas. Okay, so nowadays Pandas also provide the GPU version. So maybe if someone will have some use case for the large data set, they can try to explore this part also. Okay. Apart from this, anyone have any confusion? Any confusion, anyone? Okay. So for today, I will keep this much only. I will share the notebook file for both NumPy and Pandas. You can try to execute the code, try to see how different function you can apply, how different columns you can apply with the help of Pandas, and you can use the NumPy package as well, and you can see. Okay. Okay, that's it from my side. Thank you so much, everyone. Thank you.
Thank you, sir. Have a good day.
Thank you.
You.
Thank you.